Good afternoon, everyone. Today we will study the last section of the integral part, substitution rule. It will be the similar rule as we did in the differentiation part. Okay, if we have a more complicated function to differentiate it, then we can find the transition variable u, then apply the chain rule. Okay, apply the chain rule. So in the substitution rule, we will deal with the integrals, either definite integral or indefinite integral. So now let's start with this integral, this indefinite integral. Evaluate these following integrals. Now here the integrand is a function 2x times square root 1 plus x squared, right? So this is not some simple function we know. It's not quick to work out the antiderivatives, right? It's not really easy. So here we can introduce a new variable. We can call it the transition variable. Okay, so let me explain here. So we can let a transition variable u, okay? We usually use the letter u. Okay, I can put, since here under the root is not x, it's a function of x, so I can let this part is u. Okay, I can let this part is u. Now u is 1 plus x squared. What is my du over dx? Du over dx is pretty easy, right? 2x. And also I can shift this differential with respect to dx. We can call those du dx term interpreted as differential, okay? Differential for the corresponding independent variable. So here we can shift the dx differential to the right side. I can write du equals 2x times dx. Okay, du equals 2x times dx. Now, if we are going to evaluate this definite integral, we can use the new variable I introduced, u. So here I have u, right? I have u replace the function of x under the root. Then it should be 2 times 2x dx. Then what is 2x times dx? That will be du here, right? That will be a differential term for u. Now here you can rewrite your u. Root u actually is u to the exponent 1/2. Now let me ask someone to work out the antiderivative for this term. For root u, what is the antiderivative? (8006). Is this student available to answer the question? (8006). So here we will use the formula u to the n, right? U to the n, then the antiderivative will be u to the m plus 1 over m plus 1, right? And then plus the constant c, right? Plus the constant c. So that will be, here we get 3 over 2, right? We get 3 over 2, then we can flip the 2 to the top, then we get 2 over 3 u to the exponent 3 over 2 plus c, right? Plus c. Now this is the antiderivative about u, right? But we are asking the question, evaluate this one about x, and we know u is u is some function of x, so we can go back to the x. U is 1 plus x squared, then 3 over 2. 3 over 2 plus the constant c, right? Indefinite integral means the general antiderivative. So we should plus the constant c. Now we are going to check, okay? We are going to check whether my answer is right or not. Now let's check here with a different color. So I'm going to take the derivative of the final answer, the final function I get. Indefinite integral, we work out the antiderivative. Of course, that is the function, right? That is the function. 3 over 2 plus constant c. Let's take derivative of this function with respect to x. So here to take the derivative of this one, then we can apply the chain rule. You can let this part is u, right? You can let the part of x, the function of x is u. So 2 over 3 times 3 over 2, that will be 1 plus x squared. This exponent minus 1, 3 over 2 minus 1 should be 1 half. And since 1 plus x term is a function of x, so that will be times 2x. The derivative of c gives 0, right? Derivative of constant gives 0. Those cancel out, right? Cancel out. So we have 1 half means under the root 1 plus x squared times 2x. So that is the same. That is the same as the integrand here, right? That is the same as the integrand here. And we interpret this dx term as differential. Okay, differential of x. Okay, so that is the same as the integrand. That means the function we work out is right. Okay, is right. Now let's check what is the substitution rule we used in the previous examples. Okay, the previous example. If u equals gx is a differentiable function whose range is on an interval I, and f is continuous on I. So of course u is a function of x and should be differentiable. Okay, should be differentiable. And f is the function continuous. If a function is continuous, then the function f is integrable. But if we said a function is integrable, maybe it's not continuous, because the function f might have a finite jump of discontinuities. So let's check the indefinite integral. Okay, let's check the indefinite integral. If we are going to evaluate the indefinite integral, and inside we have a composition function, okay, like the part under the root 1 plus x squared, that is the composition function. Okay, that is the composition function. You can have 1 plus x squared as u, then you can have root u. So that is the combination of two simple functions. And the g prime, which is the derivative of du over dx term, right? Which is du over dx term, g prime. Then that can be rewritten as fu du, where the u is gx. So that means actually here, when you differentiate the function u, okay, when you differentiate the function u, you get that is the, we can write in this way, okay, we can write in this way. So when you differentiate the function u, that means you differentiate the function g. It's the same, right? You differentiate the function g. So what is, it's a little weird. Let me write it in this way. So you differentiate the function gx, so that will be g prime, right? That will be g prime. So here, the g prime times dx, okay? G prime times dx here you shift the gx to the right side, then you got du. Okay, you got du. So in the previous example we are talking about, this u is 1 plus x squared, right? This u is 1 plus x squared. But what is f? And we know u is 1 plus x squared. Of course, g prime is 2x, right? This is the function we call the gx. So u equals gx, they are the same. That is 1 plus 2x, 1 plus x squared. So g prime x is 2x. Then what is f? What is f? F will be under the root, right? Under the root. So my f g prime x on the left side, my f g prime x on the right side will be this thing. But we know this thing is under the root gx. Now what is my fu with the independent variable u? Of course it will be root u, right? Of course it will be root u. So here is function f applies on the independent variable, the whole function gx, that will be root gx. So fu will be root u. That's why we find the translation variable u, then we can rewrite it as the indefinite integral fu du. Then we work out the antiderivative for root u. That is pretty easy, right? That is pretty easy. So if we make the change of variable or substitution, okay, we call it substitution. Then from equation 3, we have this one, okay? We have this one. So here actually the f prime, where the big F prime, it's the same as the one we mentioned in the fundamental theory of calculus. The big F's derivative gives small f, okay? Gives small f. So here, this side, it's the same. It's the same as small f gx, okay? Small f gx, g prime dx. They are the same, okay? Because big F prime equals small f. It's the same. The reason we write the big F prime, so in this way we can work out its antiderivative will be fgx. So here fgx, although we know it's a composition of two functions, right? So this one is antiderivative. Of course, it's a particular one because we plus c here. So this one is any antiderivative or particular one of this function. You can write big F gx g times g prime x, right? With the integrand. This is the integrand in the indefinite integral. So here, the big F gx is any antiderivative of this f prime. F prime applies on the gx as the independent variable times g prime, okay? G prime. So why? Let's check it, okay? Let's check it. So if we take the derivative of f gx, okay, if we take derivative of this function, this composition of two functions with respect to x, so that will be big F's derivative, right? And since this is the chain rule, take derivative, so we should take derivative of g again, right? This is the df over du, right? df over dgx with the independent variable gx, and then this term is dg over dx, right? So of course this big F gx is any antiderivative of this one, then plus the constant c. That is how we evaluate the indefinite integral. Now we know u is gx, right? We let u equals gx is a function of x. So here we can rewrite it as fu. And we also understand this thing equals fu du, right? Fu du. What is the antiderivative for this indefinite integral? Or what is the antiderivative for small fu? Of course, it's big fu, right? It's big fu plus the constant c. And what is this one? This one is the indefinite integral, small fu. Those two, they are equivalent. Okay, those two, big F prime and small fu, they are equivalent. So here we can, if we are going to evaluate the indefinite integral with the composition functions, small fgx times g prime, then we can convert it into small fu du. So here makes this fu becomes much easier. Then we can work out the antiderivative big fu in an easy way. Okay, in an easy way. So now let's work out one example. Okay, let's work out one example. So I saw some students got a little internet problem. Any feedback? Any feedback? Is the internet good? No problem. Okay, so for some students it's good. Alright, I'm just double checking, okay? I'm just double checking. So maybe some students, their local internet was not working very well. Alright, so I guess most students, internet is good, internet service is good, and you follow me, okay? Now let's look at example 1, okay? Let's look at example 1. I'm going to pop up several questions, okay? So you are able to follow me. Now I'm going to set up so evaluate this indefinite integral x cubed times cosine x to the 4 plus 2, okay? So inside the cosine, it's not the cosine x. Inside the cosine is the function of x, right? It's the function of x. So I need to find the translation variable, the new variable gx, right? And also I need to work out what is du over dx, which is g prime, right? Which is g prime. And also I need to figure out what is the composition. What is the composition here, fgx, inside the for the integrand, okay? For the integrand, what is the composition? And what is my fu, right? We can write this one as fu du, indefinite integral fu du. Now let's call someone to answer the question. What is u? So 40010, from chemical engineering, I guess. So in the example 1, what is the u? What is the function u? Or any other students get the answers? So no reply. Let me continue, okay? Let me continue. Yes, we get one student, okay? We get one student's reply. Here, the u will be the function inside the cosine. If we let u is this function, then that becomes cosine u. It will be easy, right? It will be easy to deal with the antiderivative about cosine u. So since u is this polynomial and it's pretty easy, right? It's pretty easy to take derivative. Du over dx will be 4x cubed, right? 4x cubed. Now here you can rewrite du is 4x cubed times dx, right? You can shift the dx differential term to the right side. So du equals 4x cubed dx. Now from the integrand, if I write the u is x to the 4 plus 2, what is my fgx? What is the composition of two functions? So that will be cosine gx. My gx is this thing, right? This is my, so that means it's cosine gx, right? Cosine gx. So what is my fu? What is function f? We need to figure out what is small function f. So that is called cosine. So fu will be cosine u, right? Now let's check it, okay? Let's check it. So here x cubed cosine x to the 4 plus 2 dx. Now I'm going to rewrite here. This is fgx. This is the term fgx, right? This is the term fgx. So this is a term fgx. Now somehow I need to find my g prime, right? My g prime. But here it shows the g prime is 4x cubed. Now this, we only have x cubed. So what is the relation between x cubed and g prime? So here we can rewrite, we can divide it by 4 on both sides, right? We can divide it by 4 on both sides. So x cubed actually equals 1 over 4 times g prime, right? 1 over 4 times g prime. And here you can move your 1 over 4 outside. So here inside the integrand, this is not gx again. This is 1 over 4 g prime x. Okay, this is 1 over 4 g prime. So I can remove this 1 over 4 g prime outside. Then that becomes f gx inside times g prime dx. Right? Then we can, according to the substitution rule, this part we just keep the constant outside. This part equals the indefinite integral fu du, right? Now it's pretty easy. Now what is my fu? Fu is cosine u. What is antiderivative for cosine u? It's very direct. Sine u, right? Sine u. Here you might write sine u plus a constant c1 like that, right? You work out the indefinite integral first. And then that will be, we go back for sine u, that will be 1 over 4 sine. My u is x to the 4 plus 2. Here, plus 1 over 4 times constant c1, we can just use the constant notation c to denote this part. No matter what the number it is, just a constant, right? Just a constant. So that is the integral, right? And the indefinite integral gives a function. Now, if you are not so confident about your final answer, now let's check, okay? Let's check. Since this is the antiderivative, antiderivative, let me just check, okay? Let's check it. Let's take the derivative of this term. So d over dx of this function, 1 over 4 sine x to the 4 plus 2 and plus constant c, right? So we are going to take derivative with the chain rule because inside the sine it's a function of x. So it's sine u, chain rule, cosine u. And then cosine u du over dx. U is x to the 4 plus 2. So du over dx gives 4x cubed. And the derivative of the constant c gives 0. So 4 and 4 cancel out. We have cosine x to the 4 plus 2 times x cubed. Let's check it. That is the integrand inside, right? That is the integrand inside. So that means the function we work out, it's right. Okay, it's pretty easy. Okay, but the important part is you should find the convenient transition variable u. Okay, you need to find the appropriate u as the chain rule part we did. And of course, this polynomial is differentiable on all the real numbers. It doesn't matter. Okay, it doesn't matter. It's always differentiable on the real numbers. So here, let's check the solution. We make the substitution for u, and we know that is gx, right? We know this is my gx, and its differential is du over dx is for x cubed. So we can write dx to the right side. And here, we're using this substitution because we only have the x cubed times dx term. So that will be 1 over 4 du. And then apply the substitution rule, right? Substitution rule. This part is cosine u, and then this x cubed and dx, which is 1 over 4u, right? Move the 1 over 4 outside. So here they just combine the constant directly. So it's pretty easy, okay? Pretty easy. Now, example 2, evaluate the indefinite integral cosine 5x dx. So here it seems like we just have one function, okay? Just one function as the integrand cosine 5x, right? And according to our experience, we might call u is 5x. We might let u is the gx equals 5x, but we don't have the g prime part, right? It should be fgx, the composition of fgx, but we don't have g prime. Now let's check it, okay? Now let's check it whether we can apply the substitution rule or not. This is a pretty simple function for u. My u is gx, which is just 5x, right? Which is just 5x. Then du over dx, which means the derivative of g. Now it's pretty simple, just 5, right? Just the constant 5. Or you can, now let's answer what is fgx, okay? What is fgx? Fgx will be cosine 5x, which is cosine with the gx inside, right? With the gx inside. So my function f will be the cosine, right? So fu should be cosine u, no problem, okay? Fu will be cosine u. We need to figure out each part, then we can apply the substitution rule. Now let's evaluate this one. Cosine 5x dx. Now I can write it as f. This is the fg prime, right? This is fg prime. So this thing is fg prime. Now where is my g prime? Here we don't have any special term. You can take it as 1 times cosine 5x dx, right? Then what is the relation between this 1 and g prime? My g prime is 5, right? Here we work out, it's pretty easy. My g prime is 5. So of course here will be 1 over 5 g prime, right? This is 1 over 5 g prime equals 1, right? Divided by 5, right? Divided by 5, that is 1. That is 1. So here you can rewrite it as, you can remove the 1/5 outside of the integral sign, and then you have the g prime, okay? You have your g prime. Your g prime is 5, and then times cosine 5x, right? Now let me explain a little bit. So here cosine 5x is the fgx, the composition, okay? The composition function. Now what is my 5? The 5 is my g prime, right? The 5 is the g prime here. So here it's fgx times g prime dx. And we just keep the 1 over 5 outside. So that will be fu du. right? It's the same fu du, but we should keep the fraction outside. So 1 over 5 cosine u will be sine u plus a constant c, right? Plus a constant c. Then what is my u? Sine 5x, right? Sine 5x plus c. And again, we can go back and check whether this function we evaluated is right or not. Now, let's check it. Take the derivative of 1 over 5. So let's check here. Take derivative of this function with respect to x. So 1 over 5 sine 5x plus a constant c. Plus a constant c. Then that will be 1 over 5. It's same sine u, right? Sine u will be cosine u. And then du over dx. Du over dx is 1 over 5. The derivative, sorry, du over dx is 5, sorry. 5, right? And then derivative of a constant gives 0. So that should be cosine 5x, which is the same as the integrand here, right? Integrand here. So our final answer is correct. Where we comes the 5, 1 over 5, because here you can take the inside. So the question asks, okay, where we comes with the 1 over 5, the fraction. Here, in the integrand, you can take it as 1 times cosine 5x, right? 1 times cosine 5x. So here, 1 equals 1 over 5 g prime x. What is my g prime? Because my g prime is 5. Here, u is gx. Gx is 5x. So g prime is 5. How can we get 1? So it should be 1 over 5 gx. So you can reply here. Because we are trying to write it as the format in this way, fgx times g prime. And especially we notice that here the g prime is a number, okay? G prime is a number here. It's 5, right? It's especially just a number. It's not an x term because it's a linear function. The derivative gives a constant. So only in this format, that's why we need to create the g prime, okay? We need to create the g prime. G prime is 5, so we can move the 1 over 5 outside. Since you add the 5 as a g prime here, then you have 1 over 5 outside of the integral sign. So that will be fu du according to the substitution rule. Okay, it's a very good question. If you couldn't understand some manner part, okay. I think it's almost time. We can take a break.